Okay, so I've got an element, and I want to find, I've got some stresses, state of stress on the element, and I want to find what the stresses are acting on that inclined plane AB. Now, to solve this is pretty simple. The more difficult thing is to figure out what we're doing. And really all we're doing is we're looking at it in a different uh, orientation. We're just reorienting the object, seeing what kind of stresses we have in different directions when we do this. However, when we do this, the equation quite simply becomes, if I want to find my new x prime axis, this would be an axis at, at that angle of 60 degrees up like that, or actually it would be if you rotate it 30 degrees up. Ultimately, what I'm going to do is I'm going to look at an element in this orientation right here, okay, where we rotate up 30 degrees like that, okay? So this line and this line are in the same direction there, okay? So to find that new stress in that direction, we just use the following equation. Let me just write it down. It's just kind of plug and chug at this point. Okay, but it's a pretty simple equation that we just use, plug in our current values, and then plug in to get the new values we want at this new angle, theta, right here. And the theta I'm going to use again is 30 because I'm rotating up 30 and orienting it that way, even though I've got that 60-degree angle there, but it's rotating in the opposite direction. Okay, so going ahead and plugging in my values here, I can find my new x prime axis. This will be the one up and to the right, and I can just plug in -5 because the x is in compression there, okay, plus 8 over 2. Again, the y is in tension, so it's plus, okay, plus -5 minus 8 over 2 cosine, and then it's going to be 2 times 30, okay, because again, I'm rotating up 30 to get to that angle that's shown there, okay, and then the shear stress, okay, is downward on the right side, so that's actually a negative, so it's going to be -2 times the sine of 2 times 30. And really that's all there is to it. It's a pretty simple plug and chug sort of situation, and I get -3.482 KSI. So what this looks like now is on that new X surface, it's going to be in compression, so inward like that, and it's going to be 3.482 KSI. Okay, I do the same thing in the Y direction. Really the only difference is it's a change of sign here. Okay, so that's going to be -5 plus 8 over 2, and now it's going to be minus -5 minus 8 over 2, and that's really the only difference is that negative sign right there. That'll be times the cosine of 2 times 30, okay, and this will be minus a negative, so there's a negative sign in there, 2 sine times 230. So in that new y prime direction, I get what's equal to 6.482 KSI. Okay, so I would draw that. It's positive, so it's going to be out in tension like so, and it's going to be 6.482 KSI like that, right? So just reorienting this, my axes, I can find what the stresses are along those directions as opposed to the horizontal and vertical that I'm given. Now I can find my new shear stress, tau x prime y prime, given by, again, it's just a plug and chug equation here. Okay. Sine of 2 times 30, okay, plus -2 cosine. And again, these equations are in your book. It's really just plugging and chugging. More importantly, kind of figuring out what you're actually figuring out is probably the most important thing in that element, okay? So now that is given as a positive 4.482 4.63 KSI, meaning that on the right side it's going to be up instead of down like it was. That wasn't the best drawing there. Try it again. Okay, so the shear stress will be in that direction as it's flipped that angle right there, and that's going to be 4.63 KSI. So again, these aren't too tough. It's just a plug and chug sort of situation. Just grab the equation and throw it in. But again, more importantly is figuring out what you're looking at. And again, if I'm trying to find at a specific angle, I'm just kind of rotating the axes, figuring out what the stress is along those axes or what I'm looking for.